Good morning, students. Myself, K.K. Leka, Assistant Professor in the Department of Biomedical Engineering in Erode Engineering College. In today's session, we are going to see about nature and properties of X-rays. Okay, let's get into the session. Before that, we have to know about the X-ray. X-rays, X-rays are basically it is a type of radiation. It's also called as electromagnetic waves. It is an imaging that creates the picture of our inside body. The images show the parts of your body in different shades of black and white. Most similar use of X-rays is checking of our fractures like broken bones, but it can used for in some other ways also. Some other ways are like bone fractured breaks and problems affecting the soft tissues and internal organs and other ways of uses of X-rays. It is basically having the shorter wavelength and also it has a higher frequency. The wavelength is mainly ranging between the 10 power minus 8 to 10 power minus 12 meter. In frequency, it has a frequency range between the 10 power 16 to 10 power 20 hertz. This is the chart for different types of wavelength. There are different types of rays: gamma rays, X-rays, ultraviolet, infrared, microwave, and also short wave, long wave. There are different types of rays, but we are considering only X-rays. In X-rays, the wavelength is ranging between 10 power minus 8 to 10 power minus 12. But in frequency, it has a frequency ranging between 10 power 16 to 10 power 20. The gamma ray has the higher frequency and more shorter wavelength. In other words, the long wave has the longer wavelength and also smaller frequency. Okay, let's go into the nature of X-rays. X-rays have similar to light waves. It is very similar to light waves, but is having the much shorter wavelength than a light waves, about 10 power minus 10. The wavelength of visible light is nearly 10 power 3 times higher than a wavelength of X-rays. Wavelength of visible light is ranges from 4000 amps to 8000 amps, while in a wavelength of X-ray generally lies between 1 to 2 amps only. 10 power 3 times more than a X-ray. The light waves are 10 power 3 times more higher wavelength than a X-rays. When coming to the frequency, it is just opposite, which means if it has a shorter wavelength, it must have higher frequency. So the wavelength of the frequency of the X-ray has a more 10 power 3 times higher than a visible light. Again, since the energy of the photon is directly proportional to the frequency, so the energy of photon is stronger than a visible light. Okay, it is a shorter wavelength, higher frequency, and also energy of the photon is higher. This picture shows the different types of effects. There are different types of effects like Compton effects, photoelectric effects, pair productions. Okay, first one is Compton effect. Compton effects means it is a scattering. It is a type of scattering. Compton scattering is an example of an inelastic scattering, in which the scattered radiation has a longer wavelength than a wavelength of the incident radiations. The scattered electrons has a longer wavelength than an incident wavelength. The incident photon heats, the scattered photon is comes out, and also the first electrons also comes out here, but the scattered photon has a longer wavelength. In the next one is a photoelectric effect. It is an effect, the phenomenon in which electrically charged particles are released from or within the material when it absorbs electromagnetic radiations, which means the incident photon hits the electrons, and the first electrons are produced, and also the characteristics X-rays are comes, and there is a vacancy in the emitted X-rays, vacancy in the K cells. Okay, let's comes to the pair productions. It is a production of electrons, the pair of electrons, which either it is a positive and also negative electrons. The incident particles hits directly in the center, and electrons positive and electron negative is produced. The production of two electrons known as pair production. It is a direct conversion of radiation energy to a matter. It is a direct conversion of radiation energy to a matter. Okay, next is characteristics of X-rays. The X-ray characteristics depends on the wave nature and particle nature, how the X-rays waves are produced, and also how the electron particles are penetrates in an X-ray. This image shows the different types of rays, and basically X-ray has a decreasing wavelength and also increasing frequency and increasing photon energy, but it directly opposite to radio waves. How it penetrate, and the picture is how the fractured bone is shown in the image. X-ray image of the body are an indispensable diagnostic tool in modern medicine. Medical imaging allows for a non-intrusive detection of dental cavities, bone, foreign objects, and diseased conditions such as cancers. We are using the X-ray. Standard X-ray images easily between the bone and soft tissues. In addition, the contrast between the different areas of soft tissues, we have to inject the contrast medium. Either it will be a liquid or a gas that is comparatively opaque to the X-rays. The previous image, the photograph shows black and white particles and also the broken bone. If you want more contrast, we have to add the contrast medium. This is the electromagnetic spectrum. The electromagnetic spectrum is an entire distribution of electromagnetic radiation according to the frequency or the wavelength. According to the frequency and wavelength, the entire distribution of electromagnetic radiation happens. How the electromagnetic radiation happens in an X-ray means it has a frequency, as already said, higher frequency, and also temperature of the body emitting the wavelength. If you are emitting the X-ray, how the body creates temperature, how the temperature of the body emitting the wavelength. The temperature is basically very low. Basically, electromagnetic radiation is created when an atomic particle such as electrons is accelerated by electric field, it causing to move. Magnetic and electric fields of an electromagnetic wave are perpendicular to each other and the direction of the wave. The next is X-ray absorption spectroscopy, which is also called as XAS, and X-ray fluorescence spectroscopy, which is called as XRF. Basically, spectroscopy is a tool. It is used for studying the structure of atoms and molecules. The main Types of atomic spectroscopy is atomic absorption spectroscopy, atomic emission spectroscopy, and atomic fluorescence spectroscopy. In X-ray, we are studying only X-ray absorption spectroscopy and X-ray fluorescence spectroscopy. In X-ray absorption spectroscopy, it is an instant X-ray of energy E, which is absorbed, and it destroying the core electrons of binding energy E naught and emitting the photoelectrons with kinetic energy. The kinetic energy is E minus E naught. The X-ray is absorbed, energy is absorbed, and it is destroying the electrons of binding energy and emitting the photoelectrons with some kinetic energies. The core state is eventually filled, ejecting the fluorescent X-ray or an Auger electrons. The core state is completed. It ejects either a fluorescent or an Auger electron. X-ray absorption spectroscopy is a widely used technique for analyzing the chemical environment of elements. In an unknown material. It is used to determine the local geometric or electronic structure of any material. The photo emission principle is when an X-ray bombards a sample, some electrons become excited through enough to escape the atom. Some electrons become excited enough to escape the atom. It is the basic principle of the X-ray absorption. The X-ray absorption intensity is based on the viewpoint of the Fermi-Golden rule. Wi to F is equal to intensity frequency is equal to 2 pi by H m square G of HW. And m is an metric element. M is equal to F H I in the frequency, H and I intensity. The electric dipole perturbation associated with a photon in G of H omega is the point joint intensity of states separated by the energy. This is the graph chart how the intensity of X-rays happens and the photon energy produces with respect to the absorption of the X-rays. Initially it is higher and comes to lower and strategically increasing in a constant way. The rulers for small sizes, photons and electrons. First, how the X-ray penetrates in a cell and also in a water molecules. In cell like soft tissues and all, it has a higher wavelength, but in a water molecules it is a very smaller wavelength. The synchrotron radiation is equal to photons with a tunable wavelength 10 power 4 nanometer to 10 power minus 3 nanometer. The next is the scattering factors, atomic scattering factors. How if the energy is absorbed, photons produced and also electrons produced, and also some scatterings also produced. Absorption is happening means scattering also happening. The interaction of light and atom of photons in the energy range of ultraviolet to soft and hard X-rays is between greater than 30 electrovolts and can be expressed in terms of scattering factors in forward scattering position. How the refractive index and also scattering and absorption coefficients are happens. There are some types of scattering. Some examples of scattering. The first one is isotropic scattering from a point of object. If the object is a point, how the scattering is happening? It is happening in all the directions. Scattering happens in all the direction in first picture, and then in next picture and B, it is non-isotropic scattering from a partially ordered system. It is the partially ordered system. In edges of the partially ordered system, the scattering is produced. In the next image, in image C, the diffraction by an ordered array of atoms as in crystal. If in a crystal-like particle, how the scattering is happen? It happens in a opposite directions. It hits and comes in the opposite direction. In next image D, the diffraction from a well-defined geometric structure such as pinhole-like structure, how the scattering is happening. The pinhole-like structure has a long straight line, and scattering is happen in some directions. In refraction at an interface, if it is an some interface during the penetration, means how it happens. N is equal to 1, the incident is happening, n is equal to 1, and the refraction which means scattering is happening 1 minus lambda plus 1 beta, I beta. In total external reflection, the refraction is happens only in externally, just like the crystal-like particles. Crystal-like particles are at in some angle, but in the angle is just smaller. The absorption process spectroscopy. The photo absorption is a transition process between the quantum states. It excites a core or valence electron into a previously occupied bond states, quansi band state, or into a quantinum state, which means excitation states and also ionization photoelectric effect. The photon can be regarded as an oscillating hammer. The oscillating hammer hits, the oscillating electric field act as a perturbation to the system. The hammer knocks the electron out of the core orbital, and the oscillating frequency is also produced. One absorption length, how the one absorption length to be calculated? It is also known as the 1 by E alternation length, or simply alternation length, by which the incident photon flux has been alternated to 1 by E is equal to 0.368 or 36.8% of its intensity. One absorption length is an often used as an optimal length for the thickness of the sample in XAFS measurement for the best signal to noise ratio. What happens after absorption? If the absorption process is happened, what is the next process? The next process is nothing but de-excitation of the atom with a core hole. It is mainly based on the two primary process. First one is Auger and is X-ray fluorescence. Auger means it is electron channel favorable route for shallow core levels and low Zell elements. Auger electrons has a electron channel favorable route for shallow core levels and low Z elements. The X-ray fluorescence has photon channel favorable route for deep core levels. Subsequent processes include cascade effect formation, fragmentation of the molecules also happens as a subsequent processes. And also luminescence. The center picture shows the core hole state, and the left side is auger, and the right side is fluorescence. In the augers, the core hole is the electron hits the core. The auger electrons is comes out, which is equal to K is equal to B core minus B of 1 minus B of 2 minus F of 2 hole. The 2 hole process is happens in auger electrons. But in a fluorescence, when the electrons hits, the X-rays are produced. The next is X-ray emission lines. How the X-rays is penetrated in M cells, L cells, and also in K shells. And also in the next picture, in the right side picture, it has a fluorescence yield for K and L cells. How the fluorescence yield is happened between the K and L cells with respect to the atomic number. In the K cells, it has a higher range of fluorescence yield. In L cells, it has a just average number of fluorescence yield. The auger yield is equal to 1 minus fluorescence yield. Thank you. Thank you for watching my video.